All right, so let's look at an example. Um, Here we're looking at two population means where the population standard deviations are unknown. And this is an example where, even though the population standard deviations are unknown, they're thought to be equal. And we're looking at sample standard deviations that are approximately equal, as well as sample sizes that are large and approximately equal. So given two sample data sets of birth weights of boys and girls, test the claim at birth, girls have a lower mean weight than boys. Assume the distribution of birth weights of boys and girls is normal, and the population standard deviation between boys and girls are equal. Given sample dataset statistics, okay, we've got a sample size of 195 boys with a mean weight, I think this is probably grams, 3,272.82 grams, and a standard deviation of 660.15 grams. And then girls, 205. Let's see. Okay, my computer is taking a moment. Here we go. All right, so we've got uh, a sample size of 205 girls with a mean weight of 3,037.07 grams and a standard deviation of 706.27. So let's look first at step one, which is our given information. So we've got a mean weight, say for girls, standard deviation for girls, and a sample size for girls. We're going to call this X bar 1, S1, and N1 because we're going to need uh, um, that labeling for the calculator function. And then we'll have X bar boys, S boys, and sample size boys. We'll call that X bar 2, S2, N2. All right, so what's nice is this was already already presented to us in a pretty clear format here. So we want to test the claim at birth, girls have a lower mean weight than boys. So the mean weight of girls is lower than the mean weight of boys. This is our original claim. All right, so this also means that if we're talking about a population mean, we're going to use mu1 to be the population mean of girls and mu2 to be the population mean of boys. Okay, so here mu1 is going to be substituted here for mu g, and mu2 will substitute for mu b. So we'll put mu1 less than mu2. And that's our original claim. The other thing too is I don't see anywhere here where it talks about confidence level. So here you'll notice that confidence level is missing, which means we can imply that the confidence level is 0.95, which then infers we're going to have a significance level of 0.05. Also, we do not know what sigma 1 and sigma 2 is. That is unknown. But because we're talking about, the weights of human beings, and, I mean, it doesn't matter the gender at birth, they're still human beings, and we can assume that the standard deviations of both populations will be the same. So even though that's unknown, we still know that the standard deviation for the birth weight of boys is going to be equal to the standard deviation for the birth weight of girls. And because of this, we're going to be able to pool the standard deviation. Now, the sample standard deviation of girls and boys have a relatively similar magnitude. Let's see here, what else? Sorry, I'm trying to scroll down, but there we go. Our sample sizes from the two samples, these also have a relatively similar magnitude. The sample size for girls is greater than 30. The sample size for boys is greater than 30. So what that means is these sample sizes are considered large. Okay, so this is a lot of information that we've got here. So let's proceed to step 2, which is to set up our null and alternate hypotheses. So we have this hypothesis here, mu1 less than mu2. That is our original claim. And so the complement of that will be greater than or equal to, because it's equal to, that's our null, that's our alternate. And because of this inequality being less than, it looks like an arrow going to the left. So this is going to be a left-tailed distribution. All right, step 3 is now we want to calculate our t-test statistic as well as the relevant p-value. So this is where we're going to use these two calculator functions. All right, let me try and make sure that I get everything correct. So this is going to be x bar 1, this is S1, and that is N1. And this is x bar 2, S2, and N2. All right, so x bar 1 is 3037.07. See here, S1, 706.27. N1 is 205. X bar 2 is 3272.82. S2 is 660.15. And N2 is 195. And our alternate hypothesis, I should probably come down here, is going to be less than mu2 right there. And because the population standard deviations are assumed to be equal, we're going to put yes for pooled. All right. Now that's for the Texas Instruments calculator. For the NumWorks, you want to make sure that we do a test for two sample means, but choose a pooled t-test. All right. And if we're going to take this inequality, mu1 less than mu2, and we want to put it in this format that NumWorks uses, okay, we're going to need to subtract mu2 from both sides. And we have mu1 minus mu2 is less than, so I'm just carrying this down, 0. So this is the option we're going to use right here. All right. And let's see here. X bar 1 is going to be 30, 3707. And then S1 is 706, 27. And N1 is 205. X bar 2 is 32, 72, 82. I'll try and scroll down a little bit. Yeah, my laptop keeps freezing on me here. All right, so let me rewrite this. 32, 72, 82. S2 is 660.15. N2 is 195, and the significance level is 0.05. All right. Ooh, got a little bit of glitching here. I didn't notice it before. Let me try and clean this up. There we go. Test and p-value. All right. So let's now go to Texas Instruments. Figure this out. All right, so we'll hit Stat. We'll go to Tests. Okay, so now because the population standard deviation is unknown, we're going to do a two-sample t-test. We're going to be using stats, and now we just have to put in our values. So this is 3037.07, standard deviation of 706.27, the sample size of 205. See, X bar 2 is 32, 72, 82. S2 is 660. Oops. 660.15. Sample size, N2 is going to be 195. All right. And we want the less than option, because that's what our alternate hypothesis is. And we want to turn pooled on. So let me leave that up. And we'll do the same thing over here. So we're going to go to the Inferences app, go to Tests. We want two means. Now this is where this one is a little different, and that right off the bat we have to say that we're going to have a pooled t-test. All right, so we're going to have mu1 minus mu2 equals 0. And here, this needs to be mu1 minus mu2 less than 0. That is our true alternate hypothesis there. Okay, so now we'll click Next, input statistics, and this is where we have to put in those same values. So we've got 3037.07. S1 is 706.27. Sample standard deviation of 205. Okay, X bar 2 is 3272.82. The sample standard deviation for boys is 660.15 with a sample size of 195 and a significance level of 0.05. Okay, next. All right, so there's our test statistic, our p-value, and we do need to write down degrees of freedom. So we have 398. So let me come over here. Oops. Texas Instruments, calculate. All right, so you can see we're getting the exact same numbers, right? Negative 3.445 p-value of 3.16 times 10 to the minus 4. And then degrees of freedom 398, degrees of freedom 398. And so you'll notice that if I scroll down one more on the Texas Instruments, this gives us our pooled standard deviation, 684.178, roughly. But the NumWorks calculator does not give us that. Okay. We'll hit next, but I don't think it's going to give it to us. I think this is as far as we get to go. So let's record these values down. Yep, okay. So what we actually want to put here is calculate the t-test, the p-value, and the degrees of freedom. Okay, so t-test, p-value, and degrees of freedom. So our t-test was negative 3.445, I believe. Now the p-value, that was a little bit of a fraction, if I remember correctly. 3.16, I'm just going to say 163. So 3.163 times 10 to the minus 4. That's what this e minus 4 represents. E minus 4. So what that means is that if you've got 3.163 and you multiply it times 10 to the minus 4, that means you're going to move the decimal place in the negative direction to the left 4 times. So we're going to go 1, 2, 3, 4. You put the new decimal place, and as placeholders, you put 0 everywhere there was kind of an empty space that you jumped. Okay. And so that is actually your p-value, 0.0003163. And degrees of freedom were 398, like that. Often what I see students do is when they see 3.163, and then it says E negative 4, is they just ignore this because they don't really know what it means. And so they think 3.163 is their number. Okay. You can't ignore this. Okay. Because by ignoring that, you're ignoring a factor of 10,000 to your number. And that's a large thing to ignore, right? If you owed someone $1, that's different than owing someone $10,000. You wouldn't ignore a $10,000 difference, right? So, you can't ignore this part of the Texas Instruments or NumWorks calculator answer. You have to learn how to interpret that this means 10 to the minus 4. Okay, and then you have to do an adjustment of the decimal point so that you're getting the correct value. Okay, So we got these values with both calculators. Let's move on to step 4. All right, so before we move on to step 4, I am going to go ahead and write our t-test statistic, which was negative 0.3445. The p-value, which was 0.123316, and our degrees of freedom was 398. Okay, so step 4 is to sketch our distribution and calculate our t critical value. All right, so let's go ahead and let's sketch our student's t distribution. It's close enough. Okay, the center of a student's t is 0. And, oh yeah, so what tail is this? I did not write that down earlier, did I? Bad instructor. So, oh no, I did. I got it. Good instructor. Okay. Step 2. So the alternate hypothesis says that we're dealing with a left-tailed distribution. Okay. So we're going to have a negative t critical value. This area in the tail adjacent to the critical value. This is our significance level, okay, which is 0.05. The area above the tail is our reject the null result. And the area on the other side is our fail to reject the null. All right, so before we put in our test statistic and our p-value, let's go ahead and find our critical value. So we're going to have an area of 0.05 with 398 degrees of freedom. Now there's something to note here with this inverse t function. You'll notice that it doesn't give us the option of left, center, or right. Okay, this native inverse t function on the numWorks calculator always calculates area from the left because these things are missing. Okay. With the numWorks calculator, okay, we can put 398 degrees of freedom, but here we can choose the area to the left, and we can do 0.05. Okay, there is kind of like a way around this, and this is using the program that I gave you. And I'll show that too. All right, so let's go ahead and calculate this. So let's quit out of here. We're going to go to our distribution functions. Now we're going to go to inverse t with an area of 0.05 and 398 degrees of freedom. Negative 1.649. Okay. So let's see here. That's going to be a negative t crit of negative 1.649. So negative 1.649. All right, let me show how to do that on the numWorks calculator. Actually, before I do that, let me show the inverse t program. So a program that I made, if you hit programs, okay, created one called inverse t83 right there. And if you run it, okay, so it's going to ask for the significance level, which was 0.08, 0.05. It'll ask for the degrees of freedom, which was 398. And now we can calculate where the area is. Okay, is that significance level in the left tail, the right tail, or the center? Right? Do we want two tails? So we want a left tail. It's going to chew on it for a second, and there's the same answer. So our tail to the left is a negative t critical value of negative 1.649. Okay, so if you want a little more flexibility, you can use this program that I've given you. All right, now let's look at the NumWorks calculator. So I'm going to hit home. Oh wait, before I do that, let me see what happens if I hit next. Okay, just gives us the t critical value and the p value here. All right, yeah, so that's all it gives us. And there's nothing we can kind of do here. All right, so let's go home and we'll go to distributions. We want to go to the student's t. Degrees of freedom is going to be 398. Forbidden value. Yeah. So this is going to end up giving an error. Oops. Sorry, I didn't mean to do that. Yeah, this is giving us an error because 398 degrees of freedom, that's true. Okay, but it's telling us it's a forbidden value. So how do we get around this? So to get around this, we need to go back home, go up to the calculation app, and now we need to go to the toolbox. So the toolbox is this, the second from the top button here on the main keypad. So there's a picture of a little toolbox. It also has the word paste in orange. And if you click that, let's see, I think it's going to be probability we're going to want to use. Yeah, so I think we go to the probability set of tools. You can go to distributions, students T. All right, and now we want to use inverse T. So inverse T, this looks very much like the Texas Instruments calculator now. So we're going to put our significance level and then a comma and then 398. So let me click OK. So our significance level, comma, 398, right parentheses. Let me get rid of this comma. It shouldn't be there. Okay. And we'll hit execute. And there is our negative 1.649. Okay. That is our critical value. Negative 1.649. Okay. So let's look and see where our test statistic is relative to that. So a negative 3.445, if we're going into greater negative numbers in this direction, that's going to be out here. So we have a t-test statistic of negative 3.445. And if we go straight up from that point, we can see that we're going to be in the reject the null region. This area here in the tail is our p-value. Okay, it's that area, and it is 0.000316. So if you're comparing apples to apples, okay, that tells you need to reject the null. And if you're comparing oranges to oranges, remember, if p is smaller, okay, which it is, if p is smaller, reject the nuller. So comparing apples to apples, oranges to oranges, both are telling us we need to reject the null hypothesis. And so that's step 5. Step 5 is to give our results and write a conclusion. And so we are going to be coupling rejecting the null with what was our original claim? The alternate was our original claim. So if we are rejecting the null and the alternate was our original claim, then this is going to be our outcome right here. We're going to say there is sufficient evidence to support the claim that the mean birth weight of girls is significantly less than the mean birth weight of boys and then with a 95% confidence level. Okay. And there is our conclusion. All right. So, the main hypothesis test process is the same. It feels like a lot more work because there's twice as much data to keep track of. And, kind of what this data means, our sample statistics and whether the population standard deviations are unknown and use pooled and yes or no. Yeah, that adds a little bit more complexity to it. Okay, but the basic process is still the same. So let me know if you have any questions.